like whatever.
Yeah. All right. So, hi, good morning, everyone. So, I'm Shweta. I am from Ivy Pro School here. Let's welcome Arpendu. He's going to have a wonderful, like always. We do expect a wonderful session on this Sunday morning. It's a masterclass on machine learning, and now ask Arpendu to take it over from you. Thank you.
Thank you, Shweta, for that wonderful introduction on this wonderful Sunday morning. So, good morning to all of you. So, yeah, I will put it on the agenda as in we will straight go to the business in terms of like what exactly we are just going to talk today. And yeah, and obviously feel free to ask any queries anywhere in the session, right? So let me first introduce the today's topic. So I think probably few of you guys have been attending a lot of sessions and might have attended few of my sessions or the other IB sessions. So is basically the agenda is we just deep dive into one of the core machine learning topics that's called gradient descent, and on that we'll just see that why this skill or this technique is important, and also from the perspective of that why and how the industry is moving to the next wave of ML techniques, and apart from the classical techniques of linear regression, logistic, and clustering and segmentation as well as forecasting, where there is a power play of these techniques specifically about gradient descent, right? So that's the entire agenda. So I would like you to create a shift. I think I, I'm coming with an assumption that most of you guys have an understanding of regression because that will be essential for this class. Uh, and so I like to create a shift in terms of how we are moving from a linear regression to the next level of techniques, which is gradient descent, right? So yeah, that's that. I will show you that in an Excel format and basically how it works, and and the power of it, right? So how we use it in the industry, and yeah, feel free to just ask me any queries. I will, and there's a small quiz post the session. So it's just a small quiz just to make sure that you attended it and obviously you understood it. That's more important. And yeah, so that's the entire agenda, right? So I have got a couple of persons off in offline. So Amal was your name, Amar, and you, ma'am, you uh, Khushbu. Okay, so I assume you have both of you have come here for the IV ML class, right? So yeah, so what we can do is that have a quick round of introduction from you to at least, because I will have the opportunity of like interacting with you like face to face, and the online guys can definitely like ping me their introductions, and then obviously I will introduce, and then we can get started, right? So yeah, I was having a brief chat with you, Amar, before we started. So quickly, if you can introduce, and yeah, you also if you can uh, get hold of a laptop, or if you are, Anjali, if you can, okay, perfect. Hello. So yeah, so because that would be a bit uh, in terms of following the entire session. So yeah, so Amar, you can just reduce once again, just like what's your background and all that. And
I am Amar Kumar Nayak, and I am basically from Odisha, and currently staying in Delhi. And I have completed my post-graduation regular from Utkal University.
okay,
And here I have completed my MBA Finance from City Manipal University, Delhi. Currently working in Capgemini since 7 years.
okay,
Prior to Capgemini, I have worked with EXL as
okay,
an admin executive,
okay,
and currently as a designation as senior executive,
okay,
analyst. Good. and I have handled 10 to 15 members in my team.
Great.
And I have gained experience to client handling and the successes of and I have much more experience in how to supervise my team and how to handle the team and how to prioritize my team to gain knowledge in insurance domain as well
Okay.
as finance.
Great.
That's all.
Great. So I think I've got a lot of experience in handling teams and like and overall I think it's huge. Like more number of experience than even me. I do not have so many years of experience. So obviously in terms of the works,
But I didn't get any opportunity to look after the managerial position because of that priorities, the experience in domain knowledge. That's
sure, sure, sure. But
yeah, robotics, automation. Now the company also provide the automation certification. I have gained in examine as automation certification, but not that's not much more expertise to our gain much more knowledge about this.
Okay. Okay. So yeah, but and I really believe that like you shift as per your aspirations. Right, and I think yeah, I hope specifically like we can talk about the session in particular that the session somewhere helps you. So I talked about it that this is a bit a deep dive. I'm not speaking anything generic about machine learning or analytics or data science. I've taken previous sessions where I've spoken generic. So this time I thought of speaking about specifically about the topic and this that will might help you in a particular way how this can be used.
I know little bit of knowledge in C language, C++ language, Python. Theoretically and then practically, I'm thoroughly in SQL language. But a little bit in C language, C++, Java, Oracle. That's I have no.
Okay.
Little things.
Okay. Okay. No worries. I think I hope the session is useful in some way to you. I hope that emerges out, right?
Yes.
Yeah. Hi, Khushbu. So you like intro as in so yeah. Okay. Manufacturing sector. Okay. Okay. Maintaining and refining. Okay. Okay. Okay, great. So you, so my takeaways is like you're an engineer profession, right? So always have great respect for engineers. Right? My parents wanted some at one point of time to be an engineer, like usually the Indian parents want. But yeah, so and it's more related to so manufacturing data, refining them, seeing what's the trend, if there are any. I'm not sure. Um, uh, how is the and how do you use that data in terms of so what's the nature of the data which comes up to you? How it like how is it? It's in Excel formats or and what do you do exactly with that data? Mhm. Other softwares. Perfect. Okay. Okay. Yeah. Sure. Uh, yeah. So I think you are trying to log in through the phone. Yeah. That's fine. So you can at least reduce the speaker volumes. That will just have the echo. Yeah, hope all in case the voice is clear. I know a bit of echo. Great. So yeah, again, Khushbu, I think as in the session you might just understand, may not specifically like whatever doubts you have, you might have some doubts. The session might not really answer all the doubts, but you might feel free to ask me. But then we will talk about certain things and you might get understanding of what's happening, what's not. So I will try to keep it very simple. I'm not using any R even. We'll try to keep it very simple in terms of understanding a particular technique, not getting in the mathematics of it very deeply, but like understanding that why it is used and how it's basically useful, right? So the entire topic of gradient descent, like you can Google it, but maybe it's like maybe kind of the first thing that okay, what's that, and how and what's the use of the analytics and data science. But I will talk about it once I speak up more about it, right? So yeah, great. Thank you, Kuku. And yeah, it's been again just for the I know your network, but then yes. Right, right. Yeah. Okay, yeah, you mentioned that. Yeah, yeah, yeah. Agree, agree, agree. Right, right. Totally. Right. Yeah, yeah. Yeah. Great, great, Jasmine. So I think for you, you're more settled up in of how we do, how we deliver. So yeah. So again, it's not something that we do in the regular classes, both in R or in SAS. So it might be a added understanding of what it is, and I will tell you that how it can be more useful and how you can explore more. Okay. So yeah, there's another of the algorithms of what we basically cover, and it is applicable to many. And I will speak about it. I will speak more about it as I go along. So now coming to the online guys, let me quickly just uh, get an understanding of you guys. Uh, so Sharpnik is a hedge fund analyst. It's MBA and economics, BSc with economic statistics, certified in big data at Ivy. Great. Hi, hello, Akash. Hope you're doing great at Genpact. Good to see you. Okay, so online guys, if you can also quickly drop your intro. Yeah, so that would be great. I might not be able to read loud for all of you, but then I hope that I can see through and can't hear you for all. There might be some issues with the hearing with this hearing thing on the network, but then is it like for all? I hope you can hear me. All done, guys. Okay, perfect. Okay, so let me quickly introduce myself. So my name is Arpindu Ganguly, and I've been associated with IV for the last years, kind of more than 2 years, as a trainer in Delhi Center itself, and specifically about R and SAS. Apart from that, I'm part of the Accenture Applied Intelligence team, working with them also for kind of 2 years, more than 2 years now. With the total years of like 4 years of experience, 3 years in data science. My background is in economics, right? So not great as like you, ma'am, and you, ma'am. Like you have a lot of engineering and mathematics experience. I do not have that. Neither not having a programming experience also. So I keep on telling that I do not come from a programming. So I keep myself as the most lamest example of someone who can transition. Obviously, I had a lot of interest since my graduation days of getting into this space. So it's just like the interest which how did I get into it? It's not like I did not do anything which is hugely. It's simple. Since I had economics background, only that thing had helped me to just get an understanding of the techniques. Obviously, R and SAS was not being taught in the university days, but I just kept on. I kept on doing a few online courses. I kept on ensuring that in my current role, when I was more into management consulting, getting into more into analytics kind of a work rather than more of a research and consulting. On the job, yes, on the job. So and then I simply tried to switch, and that's how it happened. So I would say like it's just the interest and the certifications, yes, because I keep on saying that people keep on asking me that if I do not have this years of experience, then how can I shift? Will that years of experience will make count and all of that? So I keep on saying yes, I'm an example of that. I shifted like my 2 years of experience was not exactly in the analytics field or data science field, but then I moved and somewhere I'm also trying to learn and see pace with this industry because this industry is changing or evolving very very fast. So even for me, also we see that a lot of things are happening. A lot of companies, a lot of teams, a lot of people around the world are doing a lot of things, and I also see that okay, I need to buckle up, right? So that's the power of this industry, and obviously that is a in that way it provides a huge growth opportunities, right? So that's the plus point of it. So uh, on one point you can say that okay, my N years of experience may not get counted. On Nikhil, if you can please mute yourself. I'm sorry. You lost the connection. Uh, it's you're connected to the Wi-Fi. You're not connected to the Wi-Fi. Okay, so the meeting ID is 675903765. So that's the meeting ID. Right. Yeah. Okay, so there's some of echoing. Nikhil, if you can please mute yourself. I think you are unmuted. Sorry, but please. Nikhil, I'm waiting for you. I'm sorry, but if you can hear me, if you are there. I hope so online guys, I hope you are able to hear me loud and clear. Yeah. So
Then next
sorry. Hang on, just hang on. आप उनको don't worry, you guys. We have not started. We are not missing out. Don't worry. Okay. I'm there. When we start really with the presentation, I will ensure that you are seeing it. Okay. So yeah, so I was talking about this years of experience and transitioning. So my with my limited knowledge and experience is that the growth opportunity is huge. So even if you lose, let's say, out of 10 years minus K of experience, still if you are passionate, you can like grow in a significant small amount of time in a much more exponential way. So that transition, so that growth as compared to your current role in the current industry as compared to a data science role is very, very exponential because the opportunities here, as I see, is huge. And there are very, very few professionals who really know the science in and out. A lot of people, I also say, I say quite bluntly that I'm a learner, I'm a practitioner. I am not one who has a lot of, I would say, I'm not a PhD in data science, right? So I'll not say that I have a huge amount of knowledge and experience in depth, but I'm more of a practitioner. I keep on learning by doing, and that's how I try to like, share my knowledge fundamentally. So that is applicable to all of you, right? So that's that. Uh, and having said that, now the industry is moving towards more of so 2 3 years before. I think in terms of the skill set, what they kept on asking is about the knowledge of certain tools like obviously R, SAS, Python, SQL, Tableau, and all of that. So I'm not about the tools per se right now. That's not the agenda for today. They also used to ask about like specific techniques like linear regression, logistic, clustering, segmentation, forecasting. Right. I'm sure if you have told them, because I cannot really tell them.
So that's too much of the math loop.
After this program.
अभी तक क्या?
Correct. Mute yourself because IV admin is in. I cannot. Uh, it's both showing in the unmuted section. आपका तो are you logged in? अभी आप लॉगिन करते हो?
नहीं, एक्चुअली में मैंने इनको लॉगिन करके दिया हुआ है।
हाँ तो किसी का तो है अभी
म्यूट
unmuted है ना तो दोनों का म्यूट है because IV admin is showing the green thing. Not sure मतलब उसमें स्पीकर पे ही आ रहा है.
ठीक है मैंने बोला हुआ है।
Okay, because that's my point. I think it's in. Okay, yeah, that's perfect. Yeah. So great. So yeah, I hope all of this is done. Like no more of technical issues. So one of the important techniques used now is gradient descent. Okay. Now I'm coming with, I'm sorry, but I'm coming with the assumption that most of you guys know about linear regression. Okay, I'm not sorry about you too because I can see in your faces. The online guys. So again for this masterclass, I have communicated that linear regression understanding is thoda sa essential. I will talk about it, don't worry, but not in much detail because I cannot cover like two things at a time. The focus is on gradient descent, so I'll skip there. Yeah.
Is it difficult for anyone to, after 9 or 8 years experience, to move forward to data scientist or analytics position? Is there any scope?
So what's your question? Is there any scope?
Yeah.
It's a binary question, yes or no?
Yes or no?
Yes, it is. There is a scope. Definitely there is a scope.
Because I have 9 year experience, but I'm not in tech engineering student. I'm just postgraduate in sociology, just arts. Then completed my MBA, then moved to business service. I want to move forward to business service to technical level.
Right.
Is it possible?
Yes, it is. You have to take certain steps. Obviously, with your current role, it might be not as easy as compared to a fresher who is maybe an engineer or a computer scientist, right? But it is not impossible. That's what I'm saying. You have to just plan it out. Maybe you have to see that if I can take the acquire that skills, right set of skills, right set of the attitude in terms of getting into this field. So definitely with that strategy, you can definitely get in. I think abhi eko nahi ho raha, so that's fine. That's fine. So yes, definitely it's possible. It's just like you have to plan it out, and maybe you talk with someone who's more seasoned. If you plan it out, okay, let's my timeline is let's say in the next 8 months I want to. You can just plan it out. Kaise kaise karna hai. You have to first acquire the right skills, practice more in terms of data science, understand what it is, and then start playing. It may not be very smooth because you have a deep expertise in one section, but you have to basically leverage that and enter into data science because more of the companies work with data, right? It somewhere or the other we are using data, but when we are working, we are moving to in some other way in terms of predicting it and stuff. Then we move into data science. It's not like we are immune to data. We are not handling data. It's just like we're not using the way it's in the use in data science. So that's I hope I answered the question.
Somehow I will be selected for any company. Does the company will hire me as a fresher or does the private?
I cannot really comment on that, because I cannot really because depends upon like the company to company and I cannot give the generic answer. But mostly they will discount your experience because it's not in the analytics field. But as I said, there's a lot of growth opportunities you can and you can capture. So yeah, but I cannot really comment ki how many years of experience and will you be really hired as a fresher or whether there will be some years of experience counted. So I cannot really judge on that at this point. That's it. Okay, so yeah, so coming back to gradient descent. So how many? So I think as you obviously know linear regression, right? You guys do not have understanding of linear regression. Okay. Online guys, how many of you guys do not have understanding of linear regression? a no will do, so I can just judge. So right now I see total of around 62 participants. It's great. I might not really fit, but still a lot of no's will still give me an idea. Not okay. So still like maybe what 10% of people do not know linear regression right now in the group. So I'll quickly introduce it to you. Okay. I do not. Let me talk about it. Then I will go to the gradient descent because linear regression is not really the agenda for today. But let's talk about it. Okay. So very in a very simple. Okay. So in analytics, obviously in very industries there are a lot of specifics like techniques and stuff. So in analytics, you solve certain problems, okay, and these are simple business problems. In any industry, there's a problem. You convert that into a natural problem and you try to solve it. So, for example, let's say, for example, Capgemini wants to predict what would be like the kind of sales forecast, maybe the IT forecast for the next quarter. Okay, quarter-based forecast. So what would be the typical way? If one typical way would be can really see that how the previous years are performing, and based on that, I can just predict. Just take an average of that, or just take a moving, just extend the formula and do something, right? In analytics, what do we do? We do kind of a methodical approach to predict or to solve a business problem. Here, I took example of like Capgemini trying to predict maybe a manufacturing data. You want to understand that, let's say, if you have a plant and there is some kind of volumes which is being manufactured, let's say some product, we want to know that if I have, let's say, three inputs, input A, input B, input C, and that is giving a result to the output, how I can mix these inputs so that I can optimize my output. Making sense? So in regression, what it does, it tries to basically solve for a target variable. So what is that target variable? It's the variable of interest. So maybe this thing all of you can really relate to rather than getting into specific industry. Very simple example, individual basis. Let's say in the next year, and this year you want to maximize your salary. Everyone has a salary, more relatable. So how you can maximize your salary? So your salary is, let's say, a dependent variable. Okay? It will be dependent upon what? Your experience, your skill set, your maybe working, your education, and your industry, your profile, blah 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 blah. Okay? So maybe your objective is that I need to predict that how much will I earn in the next 6 months, given these are my variables. Okay, so as an individual, I'm just giving a very micro example so that it's not related to the industry and people will not be confused. So you will try to focus on certain things, right? So maybe Amar will try to focus on, let's say, having more of education. Maybe Khushbu will try to have focus on more of getting more of experience. Maybe that's maybe you will try to have a focus on maybe more of networking, right? More of networking can help me to acquire a better job, get a better salary, blah blah blah. More of education may help me to get a better job, blah blah blah. More of skills, so on and so forth, right? So these are like features which can influence what? My dependent variable, which is my salary, right? So regression in this context, what it tries to do, mathematically solve an equation where you have these features, which is like your skill set, education, so on and so on, to see that which of these variables are most important to influence your dependent variable, which is in this case your salary. Right? You will try to understand that empirically through a data. One you can do is that hunch में कर रहे हो. मैं मेरे को लगता है कि मैं ये करूंगा तो ये हो जाएगा. That is what hunch thinking is, right? Another is called data-driven decision making. So I have this data. So you have a data of, let's say, 10,000 people. You will analyze that data. All of this, उनका historical data. So they all have. You have the data of the salary. You have the data of the skill set. You have the data of the education, networking, let's say, and so on and so forth. And from that, you try to make a sense that which are the features which really helps, which are basically impacting a individual's salary. So that's what regression does. Making sense? So with that understanding, you try to, in any context, now you can apply it to manufacturing context, telecom context, financial context, any context. You have a dependent, you have some independent variables, and then you try to see that which variables basically helps you to basically explain your dependent variable. And this dependent variable can vary according to the industry, can vary according to the context, so on and so forth. Was able to give a brief explanation of the regression. It's not what it is, what I said. I just try to intuitively mention what it is. Was it clear? Like for you guys at least. Intuitively, did you understand what is the regression? So there is a Y, and there are certain independent features. These features influence my Y. I need to see that which are the features which really helps me to explain my Y through an equational form. Right? So that is what regression does intuitively. I'm not getting the mathematical explanation right now. So now, what companies maybe 3 years before, they used to solve these problems like Genpact, TCS, all of these companies. Maybe 5 years down the line, company के पास project आता है, ठीक है, client. I'm just talking from data science perspective. Sorry, I'm not getting into the specifics of any industry. So let's say I'm a client. I have a business that I form from for a retail unit level. I need to see that what are the features, okay, which is influencing my sales. But let's say for 1,000 SKUs, the 1,000 stores are all over NCR. I need to see that which are the features which influence my sales. Okay, 3 years before, the client would say that 1,000 models for one store, one model. Okay, simple. Uh, 3 years before, maybe the client will say, I will give you 2 months of this time. आप मेरे को 1,000 models दो. And and then we will, and that's how we will see, right? 1,000 models, 2 months time. Now what has come? So that's a linear regression problem, right? So people will be deployed, one will do the model, take it model, solve it. 2 months time. Now what is happening is that the client wants the same 1,000 models in 1 week. So what can be then changed? क्या पैरामीटर्स चेंज हो गए? Either you increase the resources, से पहले 10 लोग थे, अब 100 लोग काम करेंगे, या you do something else, which is changing the way you are doing, right? So in that context, linear regression stage, you have to change something in a way that I do the same thing in a much faster way, right? So in that case, gradient descent comes into example.
That's the means on the transition will be less, but the resources also increase.
That's very if and then one relationship, right? So now, right now, everyone wants to do this. The huge volume of data is there. You cannot really sit and do like 5 models in 5 days. You have to complete, let's say, 10 models in 1 day. How do you do it? What you have to do, you have to automate. You have to automate that stuff. Regression, how we do is that we stepwise do the regression, right? So I'm not getting into regression because that will just like get into another space. But what I'm saying, I'm just trying to bring you the scope of what gradient descent is, right? You're trying to solve a linear regression problem. It can be a classification problem also. What is classification? Instead of a dependent variable which is continuous in nature, the dependent variable is categorical in nature, like yes and no, whether the client will, whether the customer will choose this credit card or not. Binary responses, categorical responses, right? So gradient descent can be applied in cannot here, cannot here, cannot here. For all, okay. So okay, stand by me, right? So yeah. So that's the whole point is that about techniques. Linear regression is still applicable. You have to build a model, but let's say you have to build 1,000 models. You cannot really spend that amount of time building 1,000 models. So you have to automate the modeling process in such a way that the regression kind of, again, regression in itself is like where you minimize the sum of square of errors. You still have to do that, but in kind of an automated way. So that is what gradient descent helps you do it. And it, again, as I said, it can be applied to both classification as well as to prediction problems. Got an understanding of what, as in why it is not what. Forget about the what. I'm sure that regression for you guys who do not know it, it might not be a very clear explanation because it will require time for people who really do not know it. What I'm saying is that regression or linear regression or logistic, these are like core techniques in the industry. You require to have that understanding. But now the demand is that there is a lot of models and resources are less. You have to automate that same thing in such a way that you do regression in a mathematical way, but it's automated given the volume of the data. So initially you are running, let's say, 1,000 models in 2 months. You are running now 1,000 models in 1 week. That is a transition. It's slowly happening. Okay. No, no, no. Everything is in R and Python mostly. SAS का I machine learning थोड़ा सा काम है SAS में, but I cannot really comment because we usually use Python and R. Again, the data. As I said, it can be moving data also. It also works on moving data, so that every time the data is fetched in, the model is solved and the coefficients are updated in that way. So it can be real time also, but it can be huge volume also. So as I said कि पहले कंपनी आता था, आपको क्लाइंट को आपको काम मिला कि आप ये मॉडल मेरे को 3 दिन में कर दो, एक मॉडल है 3 दिन में कर दो मेरे को रिलेशन का ये मॉडल, try to do it in 3 days. Now the task is that do 4 models in 1 day. So obviously you cannot do all of that in the same way which you were doing. You have to change your approach. Okay. So that is how where this gradient descent is useful or is coming into picture. Okay. Now I will come to that what it is and how it can be used. Okay. So how important is SAS? Okay, online guys, any queries? Any queries?
Can't hear you. Explain again.
Can't hear. For all, is it like I'm
Could
not?
you please explain gradient descent?
I will explain gradient descent, but I've still not explained what gradient descent is. But what I was explaining is that how gradient descent is useful or how it is coming into picture, right? The what part of it is not still explained. I've not explained it. But the why part of it, that why it is in picture, is that clear, or I will explain it again? Voice is echoing. Yeah, these things keeps on. Okay. Okay. So let me just try to explain you in a very simple manner. Okay. So let's say there is a model one. Okay. There is a certain variable x, which is my dependent variable, and there are certain independent variables. Okay. So let's take just three of them. Okay. Makes sense to all of you? There's a dependent variable, there are three independent variables, and this is, let's say, model 1. Now, how is the data changing? This data can be updated. Y can change like every month. Yeah, every month these X can change, right? You made a model, let's say at time t1, okay, on Y and X on this problem. Okay, now your Y and X has changed. Okay, this is your new Y and X. Okay, this is, let's say, time t2. What you can do is again build a model on the new data. Make sense? All in guys, right? But do you have that time to build again a model from scratch, or do you have to just find a way? So at time t1, you build. Okay, people who are familiar with linear regression, it will be more comfortable that you will get certain estimate like v1, v2, and v3. These are the parameter estimates, right? Of what? Of x1, x2, and x3, right? What is the fundamental equation that I'm trying to solve? Y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus plus right? This is the fundamental linear regression equation. With me? Rohit, please mute yourself. Thank you. So this is the linear regression equation. People who are familiar with it. So I have got a dependent variable. I've got the independent variables, which is x1, x2, x3, and these are parameter estimates, right? So at time t1, you build this model. Now the data has changed. So will these parameter estimates be applicable to the new data? What do you think? When at time t1, you solve this problem, right? You solve this problem, y is equal to beta naught plus beta 1 x2 plus beta 2 x2. After that, you call these estimates. Okay, after solving this regression problem. But now your data has changed to y dash, your data has changed to all of this. So your estimates will change or not change? Change, right? So again, salary example was relatable. So right now, you consider that education is having a lot of weight. Next year you will consider that skill set is having more of it. Data has changed, right? So that is how you have to make a new model in that case. But what if it is that you have to make a huge number of models, you do not have the time, and you have to run the models, right? So in that context, gradient descent into the picture. You will try to minimize the sum square of errors, but not through a regression problem, but through an optimization problem. So that what gradient descent is. So I will explain what gradient descent is, but I'm just trying to intuitively explain that why gradient descent. What is the use of it? मैं linear regression से काम क्यों नहीं चला सकता हूँ? अगर your data keeps on evolving, you will not have time to make the models or change the models or change your estimates, because if estimates do not change, you cannot really accurately predict your what? Y. Your Y, what is this? After fitting in this, you have your Y predicted, right? If your estimates are not accurate, so your Y predicted will not be accurate, and hence your model will not be justified. So that is basically the intuition of gradient descent. Making sense, all in guys? not what is gradient descent, but why we are speaking about gradient descent. Yes, no. Riduparna, I will answer the carry related questions maybe later on. So yeah, just hold on for that. Okay. So what I'm saying, Pyari, is that regression is a technique in data science, in analytics, used to solve a particular business problem. Like, let's say, as I was giving an example of what are the variables which will influence your salary this year, right? So you run a regression problem, you get the most significant features, that these are the features which is influencing your Y. Now, the next aspect is that if your data keeps on changing, what you have to do, keep on running or make new models. But what if you do not have so much of time to run so many models, but still get into the new estimates, and your prediction should be as accurate as the one where you built the first regression model. So that is why we require a gradient descent, where we are trying to evolve and uh, come into a scope where the GD takes into the control, and we are not running models to basically estimate my betas. Okay, so that's why my gradient descent is important or useful. Others making sense? Because if you do not understand the intuition behind it, when I start what is it, it will not make sense. But so it's important to understand that why we're talking about gradient descent. Then we'll talk about what is it. Online guys, what about you? Make sense? Should I proceed? Nitish, if you can just mute yourself. Nitish, can you please mute yourself? That would be helpful. Okay, so let's continue. And right, so again, the scope of this masterclass is that you should have some understanding of linear regression. Then it's like quite better to just understand. But even if not, just try to follow through like what I'm trying to explain. Okay. So let's now come to the concept of what is a gradient descent. How many of you people know what is optimization? I have heard about what is optimization. Optimization. Heard about it. Khushbu and Amal, have you heard about optimization? Optimization. What exactly it is? Okay, let me give you a very simple example. Very simple examples that I gave so that you can relate to. Say, take yourself 10, 15 years back in your time. So you're what, a teenager? Yeah. Let's say my mother never used to give me pocket money. Let's say your mother gave you a pocket. No, beta, sort of. Okay. What will be your objective? 100 से मैं जितना सब कुछ खरीद लूँ, दुनिया खरीद लो types. Yeah. So that would be your objective, assuming rational expectations. There are irrational expectations of this 100 से मैं कुछ नहीं लूँगा. This is meaningless. I do not value money. So I'm getting with that picture. Okay. Assuming irrational expectations, I have 100 rupees. I want to optimize that 100 rupees to get the most important things. So for you, the optimization will be different. For you, it will be different. For you, it will be different. For example, let's say you buy 2 books, 1 pen, 1. Okay, don't generalize. I'm just giving you very simple, blunt examples. You might buy a different combination of things. You might buy a different combination of things, right? But that optimization will be different. What you are doing, mechanic mindly, is that optimizing. You optimize your budgets. Do you do savings? I hope you do all of this savings. You try to optimize it. कि मैं किस में रख के मैं सबसे ज़्यादा returns लाऊं, right? That is the general sense. So that is what the intention of optimization is. So in optimization, there is a function which you either maximize or minimize. Make sense? Maximize, I want to maximize my savings. Minimize, I want to minimize my expenses. And there are two types of optimization: constrained optimization, unconstrained optimization. Constrained optimization means you have certain constraints. What is the constraint here? I just have 100 rupees. So that's the constraint. Optimization, maximize my utility. Unconstrained optimization, I have a lot of resources, nothing, I still want to optimize. So that's the difference, right? So gradient descent is an optimization problem. Okay, it is trying to optimize something. Now what? Next question. But optimization, is it clear? Clear? And guys, is optimization clear? Okay. Uh, okay. Now let me just before explaining, let me again give you a very simple example of which will maybe help you to understand better. Okay. What gradient descent is. Still, someone is not muted. Arnav, if you can please mute yourself. If you can please mute yourself, yeah, that would be great. I think you're not muted as per my list. And Nitish also. Nitish also, please unmute yourself. And
Hmm.
oh my God. I'm not sure who is Nitish. People who are unmuted, please can unmute yourself. I'm requesting it for a long time now. Yeah, sorry. Online guys, whosoever is not muted, can you please mute yourself because it's really disturbing for all. Okay, now is it visible and my voice is clear? Okay, perfect. Okay, thank you. Yeah, sure. So let's get back to the gradient descent. I'm sorry for the bit of delay. Now we were talking about optimization, right? So let's now get an understanding of what gradient descent is. Okay. Let me just copy and paste here. Okay. Can you all see my screen? Huh? Okay. So what do you see in the screen? There's a hill. There's me blindfolded, and someone has just thrown me on the top of the hill. Not thrown me, has kept me on the top of the hill. Okay. Now rationally, again, just rationally. So let's assume yourself you are the top of a hill, top of the hill, the hilltop now. You are blindfolded. Okay. What is your objective? You have to get to the ground, but you cannot see. Okay, you are blindfolded. How you will get down? Walking slowly, slowly. You will see like what is the area near you, which is the steepest one. You have to get slowly, but step by step you आपको नीचे उतरना है. You will do you will see around which is the most steepest, and gradually you will take one step at a time and get down. Make sense? Make sense? This is the intuition of gradient descent. Now I relate it to what the function is. Okay. Again, from a linear regression perspective, okay. So I have a dependent. All with me. I have a predicted. Again, the salary example. You had a salary. You predicted a salary. What is the best example of a model? Your prediction and actual is same. Your error is 0. So let's say you predicted in 2019 में XYZ salary होगा. Actually you do not know that, obviously. It's not a historical data, it's future prediction. You actually have that salary. That's the best model. Right? That's the best model. So what should be my error? 0. Make sense with me? So what you are trying to minimize here? Error. So in gradient descent, what is the minimization? Error function. What I'm trying to minimize is my error. Okay, अब error का एक function होगा. Now what is my error? Error is equal to, what is error? Actual minus predicted. I'm going in very basics. I'm not going into the mathematics. Okay. The class is not getting into the deep mathematics. It's just an intro. Just try to understand from the intro perspective.
Hello.
Yeah.
So can you repeat how we'll get error? Means because your voice is breaking actually. So can you repeat what is
Sure. Okay. So repeat again. In regression, what is my objective? My objective is to minimize the error. With me, all of you. Right? My objective in regression or any classification problem also, my objective is to minimize the misclassification error. Regression mein difference between y and y predicted should be reduced, right? Now, in gradient descent, as I said, it's an optimization problem. So I need to maximize or minimize something. So what I will minimize is, I will minimize my error, right? And what is my error? Error is my y minus y predicted. This one can write it actual minus predicted. Okay, make sense? So gradient descent works in a way that your error has to be minimized, which is also the regression problem. And what will be the, if you minimize something, if you run a differentiation, तो आप error को minimize करोगे, उसको differentiate करोगे, dy by dx, right, global minimum, global maximum, and then you will get a certain estimate, which is your beta 1 or beta 2 or beta a. I will get again to the mathematics, don't get confused, but right now just understand optimization, minimization problem, What I'm minimizing? Error. Error is what? Difference between actual and predicted, right? Now, with that, having said that, what in any gradient descent, so there is a cost function. What is cost? Cost is something that is like a cost of something, which is penalty, right? And I need to minimize that cost function. And my cost function is nothing but my error function. In case of linear regression, in case of classification, it's my entropy or my misclassification error, right? So that is what I'm trying to minimize in my gradient descent. So there is no statistics involved right now. It's more of an optimization algorithm. With me, with this, I have so. And what is the error? What is the error like? Not mean error, Akash. It's not the MAPE. You can take it as the simple error function, which is basically you can take it as the sigma of y minus y hat a whole square, which is the regression, minimizing the sum of square of errors. Okay. The other thing who are a bit familiar is that if I can draw it. थोड़ा सा खराब है. So let's say this is my y-axis, and let's say this is my x-axis. Sorry. ठीक है. So listen, this is my y-axis, and then let's say this is my x-axis. On y-axis, I have my my cost. Okay. Cost is what? Let's say your error. Let me insert this also so that it's more. This. ठीक है. Okay. थोड़ा सा ये है, but let's say this is your cost or error. Okay. And this is a number of iterations. Iterations मतलब when we are doing optimization, you run many iterations. Iteration मतलब at first iteration there will be some error. At second iteration there will be some error. You will keep on iterating until the error is minimized. Make sense? So let's say this is your cost, which is the error, and it keeps on reducing initially, and after if you keep on iterating, it will again start increasing, which is a typical U-shaped curve. It's a convex function. Not all errors will move in a similar direction, but generally the errors move in this direction. That initially it will start reducing. After it reaches a threshold, it will either remain constant or it might increase. Make sense? So where you have to reach at the minimum point, right? So this is where you have to basically reach in gradient descent. So gradient and descent. Gradient का मतलब क्या होता है? Any idea? Slope. And descent मतलब descent. So that is the meaning of gradient descent. Gradient means slope. Slope means this delta change. मतलब how much time you change so that your error is minimized. And descent is that you're descending. So that is the intuitive understanding of gradient descent means. Now, if you are observing, I'm not explaining anything about linear regression, not p-values, not t-statistics, anything. What I'm just trying to make you understand is that it's algorithm which works on multiple iterations. You just pass on the iterations and it tries to minimize the sum of square of errors and gets at a point. Okay, that is what a gradient descent does. So if you see this bowl, if you see again, this is just an intuitive understanding. At the bowl, at the bottom of the bowl is your minimum cost function. And let's say you are at this point, at like let's say at the initial top. At the initial top is there is a cost you are paying, which means there is an error. But if you keep on iterating and if you reach at the bottom, then the error is minimized, and this is called gradient descent. Okay, so the idea is you run a function in loop, you pass on the S parameters, and the itself it will give you the best result. Okay, so that is what happens in a gradient descent, because what it is trying to minimize, it is minimizing the sum of square of errors. It's an optimization algorithm, right? So let's say J theta is your cost space. Basically your idea is to reach at the minimum of the cost function. Okay, so that is what a gradient descent means. It's minimizing the error through a cost function, and it is going step by step. Okay, that is how what it is happening in a gradient descent approach. And as I previously explained, why this is useful is that if your data keeps on changing, now again coming back to the data concept, right? So what is the essential thing? आपको एक बार मॉडल बनाना पड़ेगा. Let's say at time t1 you build the model. Once you build the model, you have the estimates, right? You have the estimates, which means you have the starting points. You have the starting point of x1, x2, x3 through your parameter estimates, such as beta 1, beta 2, beta 3. And on that, there's a cost involved. Now your data has changed. You start from there, you get to the new estimates, which is new beta 1, new beta 2, new beta 3. That is what the understanding is. This साल में, let's say you have skill, you have education, you have networking. Let's say this year you gave most important weight to education. Next year you gave more important weight to skill set. Next you gave more important weight to networking. So beta is changing, or the weights of beta will change, right? And how this is changing, either you can again solve the model, and this one a gradient descent where you have the initial starting points. Initial starting points मतलब आज के date में I have my estimate of my skill set, education, and whatever networking. I run a gradient descent, I run an optimization algorithm, and I get to the new betas. And the new beta might suggest that okay, education is now more important in that aspect, right? So my data is changing, and then not build a new model. And this is very essential when you have so many more models to build. अगर क्लाइंट ने बोला कि मुझे एक महीने में इतने सारे मॉडल्स बना दो, आपने एक बार मॉडल बना लिया linear regression, right? So you have already built the model for linear regression, but again the client says that data is changing. You cannot give me the same estimates every time. The data is changing, right? You cannot give me the same estimate that okay, sales is influenced by x3 and these are the same parameter estimates. But data is changing and betas might change. So in that case, you can either again build the models, or you can run a gradient descent algorithm to update your parameter estimates. How? Because it is kind of optimizing, minimizing the sum of square of errors. So that is basically the intuitive of now the kind of understanding of gradient descent. There is a cost function. You are minimizing the cost function. That's what is happening. Every algorithm in data science, be it neural networks, be it regression, be it logistic, any kind of cost function क्या होता है? आपका actual है, आपका predicted है, इसका error का cost function. That's it. Simply predicted. Okay. So gradient descent will try to minimize your cost. Okay. Online guys with me. Since this is automated, can it lead to overfitting? A very good question. Overfitting का मतलब पता है? Overfitting का ये मतलब होता है कि let's say you have actual, okay? Actual again just relatable. Let's say you trend your salary starting from let's say 2011, and you can visualize it. It's the actual. Prediction is what you build a model from 2011 to predict your salary. What is the best model? Where your actual and predict meets, which means actual and predicted को अगर आप एक ग्राफ में करो वो सेम लाइन होगा, उसमें कोई डिफरेंस नहीं होगा if my actual and prediction is 0, right? So that is kind of called overfitting, which means it cannot be the case that you predict it right all the times, which means it is too much dependent upon that data, but if you provide a new data, it might not act as good. You're getting my point? Right now, I've built a model, let's say with 4 years of data. My action and prediction very good, 99% of accuracy, R square and all of that, right? But let's say the data अचानक से change हो गया, my model might not be able to absorb that change and might give a very bad prediction. So overfitting is not good, right? Your model should have some space of between your predicted and actual. As a beginning, it should be very different, but it should not be. They should always be sticking together. That is called overfitting. Now in gradient descent, there is a problem of overfitting. It can be a problem. कि वो क्योंकि वो minimize कर रहे हैं, उसको और कुछ नहीं पता. The only thing it is concerned is about minimizing the sum of square of errors. That is the cost function that in case of linear regression. Now there are various ways of gradient descent. There's AdaGrad method. There's a vanilla. There's an Adam method. There are variants of gradient descent which penalizes your cost function. Okay, so there can be a penalty factor which might reduce the problem of overfitting. So that is how you can reduce the overfitting. Got it, Sagnik? Okay. So if you can see my figure, the slide right now, I will zoom it thoda sa so that it's more visible. Okay. So stage 1, let's say this is the one. Okay. So this is the error. This is the starting point. Starting point of what? Starting point of your error, cost. How you are evaluating your cost? Y minus Y hat. Clear? Cost is associated with what? Error. Error is what? Actual minus predicted. So let's say there is a starting point. This starting point is when you first time built a model. Now the data has changed, right? So again you have to somewhere maybe reach here, that minimum point. So what gradient descent does, it tries to see in which direction it has to move. It can be here also. It can be here also. Any point of the convex shaped curve, right? And what is the objective? Reaching here. That is the right objective, right? But it can, and how it will reach? By taking steps, gradient, negative slope, and reach at the bottom, right? That is what happens in gradient descent. You start, you go to the next point, you again start, you again go to the next point, you again start, you again go to the next point. And how this happening is happening through your iterations. Let's say you give 500 iterations. After the model converge कर दिया in the 100 iteration itself. And the next 400 iterations, it's the same error. If you have given only 500 iterations, it has not been able to converge. Maybe you have to give 3000 iterations. So iterations and all of this will matter in gradient descent. So in machine learning, you might hear the word hyperparameter tuning. So there's something called parameter tuning. It's called hyperparameter tuning. Parameter tuning is which means independent variables. Hyperparameters like these, like learning rate, iterations, कितना iteration देना है, कितना learning rate I will come. So these are called hyperparameter tuning, which basically suits your model to achieve the best optimizing algorithm, the best optimization result. So that is what you have to basically control. Obviously, algorithm सब कुछ नहीं करेगा, आपको कुछ तो input देना पड़ेगा, right? So these are the inputs: number of iterations, number of what kind of method, whether you want to use Adam, you want to add a boost, add a grad, or a simple gradient descent. These are the things which you can choose from, right? So having said that, so this is how the gradient descent works. How do we know that what number of to give for iterations? How do we know that? What is your objective? Error को minimize करना, right? So if you see that I gave 500 iterations, your error is still very high. You might have to give more iterations. ये सब as modeling also you have to tweak. There is no like casted in stone कि बढ़ाओ कमाओ. You have to play. Everything is not like linear here. You have to play around. Like what exactly? But usually maybe you need to give more number of iterations. I'll talk about the learning rate. You need to control the learning rate and so on, so that you see that the error is minimized. And it is relative. Obviously, the best in hand will be given a picture. आपका क्या होगा? I'm not showing it in R, but in R you can generate the cost function. So you can see that each iteration how your cost is moving. Ideally, your cost should decline, right? So that is the picture that you should have when you run gradient descent. So that is how you can visualize that, how you can basically see that where your model is getting converged. Sure.
Please look at the stage to
Previous slide.
yeah.
Okay. Sorry.
Yes.
I will reduce it. But yeah.
Here stage 1 and stage 2.
Yeah.
The pointer is here.
Yeah.
And the objective is to minimize the error. Okay. That's equal to the stage. If the error is higher, it should also move toward the
Right. Let's say आप कहीं यहाँ पे हो. So you will try. इसमें तो बहुत कम iterations में you will reach your minimum. Let's say you are here, somewhere here, right? So in that case, you will sliding downwards only. You can be any point on this cost function, right? Starting off, you can be here, you can be here, you can be here, you can be here.
But my fundamental is if the previous test the error is less. So
Let's say if your error is less, let's say error is already at the minimum.
yes.
Then in that case it has already converged. It might converge, मतलब fifth iteration में वो converge कर दिया. बाकी के 450 of iterations are just it's running the same algorithm. The decrease in error is not much. Point something will decrease. Right? In the initial gradient बहुत move किया. What it is moving again? Think from the example which I gave. You are at the starting of the hill. Initially you might take more bigger steps. Right? देखोगे कहाँ पे है, फिर जब एकदम ग्राउंड में आ जाओगे वहां पे तुम क्या लोगे? You will take smaller steps. If you're near the ground, you might take small steps, but you're right at the hill. You will also try to, you might overshoot, right? और हो सकता है तुम बहुत बड़ा step ले लो तो तुम सीधा गिर ही जाओ. So these are the things which works in similar analogy in gradient descent also. If you're near to the base, you just might take few more steps and the error gets minimized. Yeah. So that's what the descent approach is. So gradient and descent मतलब समझ में आया? Gradient is what? Delta. Descent means descending. Okay. Classification also. उसमें बस cost function अलग हो जाएगा. Right? In logistic मैं नहीं बोलूँगा. Classification problem is name-based, logistic, SVM, lot of techniques are there. Classification problem simply means I have a categorical variable. Regression simply means I have a continuous variable. It is applied in neural network uses GD approach to minimize so that when you are predicting, right? So neural networks में क्या use होता है? Gradient descent. Learning rate. This is important. Okay. Now, what is a learning rate? Learning rate is something which you provide in the model. This is the input. Now, what is the learning rate? A learning rate is something, again, your objective is to basically get down at the bottom point of the convex function, right? If you give a very small learning rate, you will get down very slowly. But if you give a very high learning rate, you might overshoot and you might directly flow from one point to another point rather than reaching to the minimum. So learning rate is how quickly you want to move. मतलब gradient कितना बड़ा होना चाहिए. How bigger is the step size. So I can either take a very small step or I can take a very large step. Very small step, then I will reach to the bottom बहुत iterations के बाद. very large step, I will reach to the bottom in few iterations. But if I take a very large step, I might slide down, I might not reach to the bottom, I might get to the another end, right? So that is what is a learning rate. Now, what is the best learning rate? This is also something which you have to. There's no. It's not a function of time. It's something where learning rate is simply about the iterations में कितना move करेगा मेरा gradient. The larger the learning rate, the more you might there is possibility of overshooting. You in few iterations only it will reduce. तो अगर आप बहुत कम learning rate होगा, so what is happening? What is just try to understand it from this perspective. That what is happening after one iteration ends? My betas are getting updated. So if I give a huge learning rate, my betas might get updated hugely. If I give a smaller learning rate, it will get updated. But update होते होते I need to get cost function. So that is what a learning rate is. Okay. So learning rate is another thing which you basically do to check in terms of controlling the descent. Okay, I'm not going into the types of gradient descent. It might become more mechanical and stuff. Since it's just an intro class itself, it's kind of I know it's a bit of maybe थोड़ा सा it's kind of at the next level of ML, right? It's not the classical techniques of linear or जो हम बार-बार सुनते आए हैं. But neural networks, which is a big thing, works on GD. Okay, if you know GD, you know the back end of neural network. Neural network सुना होगा, anyone of you neural networks कैसे काम करते हैं. So in the back end, what works is gradient descent. So there is a cost function, gradient descent उस पर काम करता है. There is activation. There are a lot of things also. मैं ये नहीं बोल रहा बस gradient descent होता है, activation function होता है, बहुत कुछ होते हैं. But gradient descent से उसका cost function minimize होता है. So that's how neural network works. But the best part of GD is that if you know linear regression, you can automate your linear regression through your GD approach. Okay. Now, what I will do is I will show you this entire thing in Excel so that it becomes much more clear and from a data perspective. Okay. Right now we talk bit of theory, right? I will give you and one of the other things is that for people who are newcomers, if you want to learn any technique, first learn in Excel. Why? You will understand it very, very clearly. अगर मैं R में दिखाऊं, SAS में दिखाऊं, तो कुछ तो होगा बैकएंड में, मैं आउटपुट दिखा दूंगा और मैं घर चला जाऊंगा, right? For your fundamental, if you want to understand anything in a data science perspective again, from very scratch say, so try to you will get examples in internet, lot of examples. Try to solve that problem through Excel, like neural network in Excel, regression in Excel, logistic in regression. Of course, all cannot be done in Excel, but try so that you know कि हाँ क्या हुआ, black box नहीं हो जाए कि कोड है रन किया हो गया. You should know what the code is doing, right? So that's the reason I'm not showing it in R. Okay, I'll just show it in Excel. And this also again it's just a intro, pure intro, and you don't want to bombard it with another run a code, show a fancy stuff, and go away. My only takeaway is जितना भी समझ में आए, कम समझ में आए, but सही समझ में आए. Okay, so now I'll go to the Excel, but before that, okay, very good question. Is learning rate different for different parameters, or is it common? What do you think? Is learning now what are parameters? First question. My variables, right? So is learning rate different for different parameters, or is it common? Savnik, by the way, it's an interview question. It's an interview question. Okay. You go to an ML data scientist role, people might ask you. These are like simple nitty-gritties. कोई आपको नहीं पूछेगा code क्या होता है. You all of these things, these simple very nitty-gritties which people might ask just to test your knowledge that whether you know it ऐसे ऐसे और इतने ऊपर हाँ मेरे को definition आता है and stuff. What do you think? Is it common or different? Different? It is different. Every learning rate is different for a different variable. So you have to provide me multiple learning rates. Okay? Okay? So that your function moves. Now all of these learning एक साथ यूज होगा, but ये सारे learning rates can be different for, and you can make it common also, but ideally it should be different. Okay? नहीं, it is solving the cost function आपका y and y x है, but ये जो learning rate है ये सारे variables को लेगा, क्योंकि आपके सारे variables से क्या आ रहा है, y hat आ रहा है, so that learning rate is impacting your y hat, and from y hat your cost function is coming, and from cost function your weighting is coming. Okay? Can we go upwards to reduce error? Can we go upwards? Well, your function is always like this. It convex shape. You might be near to the this thing, so it's always called descent. It's not upward. You'll always go down, either this down or this down. Or if you're same, you stay there. It will not go upward, right? So that is why it's called a descent approach. All right, guys, with me? Understood? Anything not understood? Making sense? Understood the usability and what part of it? Online guys, offline guys seems to be more or less convinced by their faces. You can hear me, and then maybe a question of you can understand it or not. So, following all of you questions. Any questions? I assume there must be some questions. No? Okay. Let me then try to explain you the gradient descent approach in Excel. Okay. So just try to follow through. Okay, I'll give you a very simple example and just see कि क्या होता है gradient descent में. Again, R will do it in mechanical way, but in a code way, in a function way. But what really happens? Just try to very simple, basic understanding. Okay. So you can see my Excel, right? You can see my Excel, right? See, I have got only 10 observations. Okay. I have got a dependent variable which is, and this is a data, let's say, about house price versus size. So what is my dependent variable? My dependent variable is my house size, and independent variable is, let's say, price. जितना मेरा price होगा उससे मेरा house size depend करेगा. You can take it the other way around, but let's take this as my dependent. Okay. So based on this, I can predict this. Okay. So if you see this, no, I think this is not right. This is my independent. Okay. So my dependent variable is my house price. Independent variable is house size. What I mean is that among all the factors, my house size will impact my house price. जितना ज़्यादा size, उतना ज़्यादा house price. Quite logic. Right? My model should give me the price house if I enter the house size. That is what my model will do. I can build a linear regression model, right? With one variable using this house size, estimate it, I can solve this problem, right? So let's say this is my house size. What regression does? It fits a line, right? Regression basically fits a line, and what this line does, it minimizes the sum of square of errors. What is the error? Error is the difference between actual and predicted. The difference between this and this, 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 and so on, minimizing the sum of square of errors. Right? So this is the regression or the fitted line, and this is the actual line. Clear about the example? About the example, clear? Clear?
House size in the house size increases the house price increases.
Okay. Do not consider the relationship about between house size and house price. Let's say there's a dependent variable which is house price. Dependent variable matlab which I need to predict, and there is one independent variable which is house size. So for that independent variable, I can predict the dependent variable. So this is just a graphical illustration कि ये मैंने plot कर दिया house price को, ठीक है? And this is the house price versus house size. So this is how it is moving. In direction, what I do, I basically fit a line. Fit a line means I basically predict my y through a regression problem, which is through this function which is called y is equal to a plus bx. यहाँ पे x क्या है? House size. यहाँ पे y क्या है? House price. Make sense? This line? This is a random line. ये मैंने ऐसे ही plot कर दिया. Let's say मैंने regression करके ये एक line कर दिया. Okay. This line right now is a random line. I've just so regression basically fits the line. That's what regression does. And right now I've fitted a line. Okay. Don't get confused about this figure. The figure is not very essential. Let's say this is my y and this is my x. You clear about that? Yeah. This is the data. That's it. Okay. Now let's try to understand it from gradient descent perspective. You all know about this equation y is equal to a plus bx, right? If I give my x, I should be able to predict my y. What is b? B is the slope of x or the coefficient of x, which says that how many times my y will change for a unit change in x. Clear, not clear? Let me just write this equation. So, what is y? Y is not dependent. What is a? Equation for the equation of a straight line, it's called intercept. Right? What is the intercept? Intercept the value of y when x is 0. Right? This point. When x is 0, that is the intercept. What is b? This is the slope or coefficient of x. Clear? Clear? This is the straight line equation. This is the regression का equation. ठीक है? Multiple linear regression होता है तो बहुत सारे x आ जाएगा. That's it. Okay? Now let's try to solve this problem through gradient descent. Understand this. Okay? So let's say you have the a and b, which are your initial parameters. What is the a and b? Let's say this a and b. ये आपको कहाँ से मिला? ये आप लेट्स से रैंडमली जनरेट किया या आपको पहली बार आपने जब regression सॉल्व किया, you got your a estimate and b estimate, which are your parameters. Me? Yes, no, Khushbu, you seem to be unconvinced. With me? No. A and b, how did I get? So let's say, as I'm saying that again, the salary wala equation. Okay? You have, let's say you have to predict the salary every time for the next 5 years. This year you build a model, linear regression. So forget about how did you did it. If you do not know it, it's okay. But let's say you run the regression model. You have got 3 variables: networking, skill, and education. You got the estimates of skill, education, and networking first time because you ran the regression for the first time. So you get the estimates of the 3 variables, and with these 3 variables you predicted your y, which is your salary. But now in the next year, your salary is changing, which your dependent is also changing, your independent is also changing. Hence your A, B, and C should change. Data is changing, so parameter estimates should change. But the first time I got is through, let's say, through solving the regression problem. Right now in this example, let's say ये आपको मिल गया given या ये randomly generated भी है, let's say, ठीक है? आपने first time अपने regression solve किया, you will get A and B. In this example, let's say I have been given or it is randomly generated. Okay. Now this is my variable. This is my another variable. House price is my dependent, right? Let me just maximize this. This is my x. This is my y. In regression, what we do is kind of intelligently standardize the variable. Standardize matlab I basically minus the mean minus the minimum by maximum minus minimum. That's what I've done everywhere. Why I've standardized? Because house size is in what? Square feet. House price is in what? Dollars. I want to compare them in the same unit. Hence I'm standardizing. Yeah? Clear or not clear? I can see you guys at least staring at the screen. Not clear, you can ask me. Is these two columns clear? And guys also, is these two columns clear? Why and what? Why means why did I standardize? What means what I standardized? Yes, no. Why? Yes, no. No? Huh? No? Why is no? So why did I standardize no and what later on? So again, right on start. Again, education. Let's say education is in years. Skill set is let's say in a ranking 1, 2, 3, 4, 5. Networking is like how many people you know. ठीक है? Education का unit क्या है? Don't see in the screen. Tell me. What is the unit of education? Years. Number of years of education you have. Skill set is a ranking from 1, 2, 3, 4, 5. And networking is what? Number of people you know. Are these comparable? Yes or no? Yes, comparable or no? Comparable. क्यों? कैसे compare करो? Years of education को और network of people को कैसे compare करोगे? They are not comparable, right? They are not comparable. They are measured in different units, right? How can you compare them? You can you compare a chair to a human? You can compare a chair to a chair, right? Make sense? So first, in order to make them comparable, I need to make them unit free. I de-standardize it. So that is what I'm doing here. My housing size is in square feet. My price is in price. So I need to de-standardize it so to make them comparable. Right? So that is what I'm doing for these two variables, this and this. So if you see, ये अलग-अलग units में थे. Now they are more 0.11 and all of that, right? So they are now more comparable. Make sense? Online guys, make sense? Okay. Now, y prediction is what? You remember the equation is equal to a plus bx, right? So my y predicted is what? Just hang on. Huh?
Yes, sir.
Sorry, guys. Yeah. So now, what is my next role? The next role is basically to predict my y. So how I can predict my y? I can basically y predicted is basically a plus b x, right? So a is this, b into x. So that is my y predicted. So for every x, I have got my y predicted, right? Clear? Online guys with me? You can do that also. Akash. I standardize this by min max. Okay. Am I audible? Yeah, I hope. Yeah. So clear about this y trend column, all of you? Clear about this y trend column, all of you? It's just a function where I do that y predict is equal to a plus bx, and where what's a? This is a, and what is b? This is my b, and b is the slope of x, and a is basically my parameter, the intercept estimate. Okay. What formula? I'm just standardizing. I'm basically subtracting each variable by the minimum, dividing by the maximum minus minimum. Okay, so that's the formula. Okay, and now what's the most important column that I have is the error. Is this the norm for standardization? There are different formulas, Anita. So one of them is this. You can also do x minus mean by standardization, but I've chose this. You can do anything. Okay, there are multiple ways, but I choose this. Okay? It will not affect a lot. Okay. Uh, Now, if I want to go to the error, so what is my error? Y minus y hat. And what is the minimization problem? Minimizing the sum of square of errors. So y minus y hat predicted का whole square and आगे है 1/2. Now why I have done this y 1/2? Because since gradient descent there's a differentiation problem. Having this 1/2 helps me to really solve the equation simpler. So if I do when I do the delta SE by delta SA, which नीचे मैं दिखाऊंगा आपको, which is this one. So if you remember the differentiation formula, it is much better in terms of solving it. Okay. So this is the new sum of square of error. Okay. This is the new sum of square of error. So E9 and F9 is what? This is my actual, this is my predicted, and 1/2, this is the formula. Okay. Now what is my total sum of square of error? This is the sum. Clear? Clear with this table? Clear? Yeah. अल्फा बीटा सेम है, बस आपका डेटा पॉइंट चेंज हो रहा है तो आपका सम स्क्वायर ऑफ एरर अपडेट हो रहा है, एंड दिस इज द ओवरऑल सम ऑफ स्क्वायर ऑफ एरर. Okay, that's what the formula says, right? Now with this you need to apply gradient descent. So calculate the gradient, the change in SSE when the weights A and B are changed by very small value from their randomly initialized value. So what is the thing that you have to change now? Alpha and beta needs to get updated through gradient descent method. Okay. Now what gradient? Yes, MAPE is a mean absolute. Here I'm trying to minimize the sum of square of errors, which is the regression problem. Okay. So what if I'm solving any optimization problem, I take the differentiation, which भी हम लोग क्लास 12 में सॉल्व करते थे. डिफरेंशिएशन से ग्लोबल मैक्सिमम ग्लोबल मिनिमम आता था, right? Delta C by delta A. So that's what I'm trying to do. Here I'm trying to find the parameters A and B such that my SSE is minimized. So I'm finding delta SE by delta A, which if you solve will be minus of y minus y predicted, and delta SSE by delta B is minus y minus yp into x. If you are confused about these two, how I'm getting this, if you just solve that 1 by 2, वो क्या हो जाएगा 2 into 1 by 2 minus y minus yp, फिर x जब आप x करोगे, जब a के लिए करोगे तो वो 1 हो जाएगा, so you will get this, and जब बीटा के लिए आएगा तो वो जो bx है, that x will multiply here. So that is the output which you are getting when you are solving these two equations. It's simple math, simple differentiation. Delta SSE by delta A and delta SSE by delta B. What is SSE? SSE is your this function. इसको आप डिफरेंशिएट करोगे A और B के रिस्पेक्ट में, तो you will get these two. All when I'm differentiate ये SSE ये total SSE होगा ना, yeah, right? So now once you have what you are getting from here, you are getting the SSE is your cost function, right? And you are now calculating the gradients, right? Gradients of what is the change in the weights. Now what you will do is that you have got this data minimum standard, ये भी सब सही है. Now what delta SSE by delta A will be y minus yp, which is this minus this. Understood why I'm getting this? Because this is the formula which I got from here. Calculating the gradients. And error is आपका यहाँ पे आ गया. Error तो यहाँ पे आ गया आपका. This is your error class, sum square of errors, right? Here what I'm doing is delta SSE by delta A, which means I am minimizing the cost function and I'm updating my SSE. I'm updating my cost function. How I'm updating my cost function? Because this delta SSE by delta A, ये मुझे calculate करना पड़ेगा, right? And this gets updated by this function, which is y minus yp. Yp is what predicted and y is actual. So with this, I get this value. Okay, this you didn't understand. Column H and column I, these are basically the values of delta SSE by delta A. And if you sum this will come 3.30 and this will come as 1.55. This is my original SSE. This understood? This is my delta SSE by delta S. ये क्या हो रहा है? ये मेरा cost function update हो रहा है through this particular formula. Which is this formula y minus yp? This is basically your this, and delta SSE by delta p is this. This is where your gradient is getting updated because you are minimizing your cost function. Make sense? Make sense? No. Okay. So this delta SSE by delta ये समझ में हम क्यों कर रहे हैं? Why I'm doing this? Because I'm minimizing the cost function. Minimize करके मुझे क्या मिलेगा? मेरे को नया अल्फा and नया बीटा मिलेगा, which are my estimates, right? So I need to find that out, right? How do I find it out? When I solve this equation, I will get this minus y by minus y minus yp. How I'm getting this? If you solve this differentiation, you will get this. If I had a pen and paper, I could solve this. But this is the cost function, right? This is the cost function. So 1 by 2 into 2 minus y predicted. This is the cost function. तो अगर आप सॉल्व करोगे a and b के टर्म्स में, y predicted में कंफ्यूज मत होना. What is y predicted? a plus b x. When you're solving this, you're getting these gradients. And why I'm taking 1 by 2? The reason I'm taking 1 by 2, as I said, is that it helps when I'm differentiating the cost function. So that's the reason I'm taking 1 by 2 here. क्योंकि SSC में आपका 1 by 2 नहीं आता है, SSC में बस आपका y minus y hat by का whole square आता है. 1 by 2 I'm taking because I need to differentiate it just to make that equation more simpler. And even if it is a scaling, it just will not reduce the errors or not differentiate the trends of the error. Okay, so that's what is happening here. And once I have done this, we need to update the random values of alpha and beta. अब मैं update कैसे करूँगा? Alpha minus, this is the gradient descent. This is the next step. This is the descent, right? This is the descent which has happened. So my new A will be what? A minus SSE by dA, and new B will be B minus D SSE by dB. The change, right? And if you want to apply a learning rate, it will be A minus R into D SSE by delta A, and B is equal to B minus R into delta SSE by delta B. So मेरा learning rate let's say 0.01 है, initial A इतना था, and delta SSE by delta A क्या है? 3.30. ये कहाँ से आ रहा है मुझे? ये यहाँ से आ रहा है. Clear? And then what will happen? Now my new A is what? Now my new A is 0.4342, and now my new A is 0.73. What with I started? I started with 0.45 and 0.75. Now if I see my new SSC, the same formula goes on. My new SSC is 0.5. And what was my original SSC? My original SSC was 0.68. My SSC reduced, which is my sum of square of errors, and that's what the objective is. अब ये बस एक iteration मैंने दिखाया. This will happen, let's say, 1,000 times to get to the best value of this A and B, given we started with something. So first, see, these are the steps. You start with the alpha and the beta, or the parameters, right? Then what is this doing? You have to update my alpha and beta. How it will be updated? By minimizing the cost function. How you will minimize the cost function? By differentiating it. Differentiate with respect to what? Differentiate with respect to my parameters. And then I will get my new alpha, which is alpha minus delta SSE by delta A into my learning rate, and this is why my learning rate can be different, right? And then I will get my new SSE, which is again y minus y predicted 1 by 2 the whole square. This is how it keeps on iterating, keeps on updating, and your gradient is calculated. So this is a step. Delta SSE by delta A is your gradient, right? What is the change? You started with this point, now you should come to this point or this point. How that is calculated? That is calculated through delta SSE by delta A and delta SSE by delta B. And then your final, you run it for, let's say, 1,000 times, 500 times, 3,000 times. So final alpha and beta or the parameter estimate gets calculated. So that is what happens in a gradient descent. So imagine this, you just pass in the loop. आप बस learning rate provide कर दिए, आपने बस iterations provide कर दिए, it will automatically solve and it will give you the parameters. You don't have to solve 1,000 models, you just provide it in a loop. Learning rate and the iterations just input. It's a hyperparameter, right? When you code gradient descent ka R, you can code this. You can write the cost function and you can code this so that you run the model iteratively to get the which value minimize the sum of square of errors. So coding is different context. but you can, it could be like 5 or 6 lines of code. You can write a function, राइट आपका डेटा आ गया, आपका इनिशियल अल्फा, आप ये सोचो आपके पास डेटा आ गया, अल्फा बीटा आ गया, अल्फा बीटा कहाँ से आया, मेरे इनिशियल मॉडल से, आई प्रोवाइड द लर्निंग रेट, आई प्रोवाइड द नंबर ऑफ इटरेशंस, द फंक्शन इज रिटर्न, इट विल मिनिमाइज 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 मिनिमाइज, हाउ मेनी टाइम्स इट विल मिनिमाइज, नंबर ऑफ इटरेशंस आर देयर, एक ही हो सकता है 100 इटरेशन में वो मिनिमाइजेशन अचीव कर ले, हो सकता है वो 500, it will plot the cost function, and then it will go like this or it will go like this. You have to be, you have to see that वो when you see the graph, maybe you see that at the 400 iteration ही वो minimize कर दिया, but आपने 1000 iteration दे दिया, तो आप उसको improve कैसे करोगे? You will reduce the number of iterations to 400 because it will reduce the time, because every time it's running the iteration, it's taking the time, right? Or if you see, it has run till 400 iterations, but it has not minimized. It has come up till here. So you might increase the number of iterations. You might change the learning rate. Upwards is that sometimes you go like this, but sometimes is that again your error keeps on increasing. Right. But if you keep on updating the betas, what is happening? The betas are getting updating. Right, and then the error might increase after a point, right? And that's the reason that this is why it can again increase also, right? Because the parameters are changing, your error might again start increasing gradually. You start move away from your, again you think it from that you are doing a hill down, you keep on taking steps, और वो steps हो सकते हैं आपको फिर ऊपर लेके चला, you keep on going upward, right? So your difference between actual predictor is increasing and then your cost is again increasing. So that is why it can be a U-shaped curve also. Generally it is like a this curve, but it can be U-shaped also. Okay, so that's what is basically the essence of a gradient descent. Okay, it's not a classical analytical technique which we usually talk about, but it's like a ML technique which can be used for a lot of regression problems, and used for classification problems, neural networks, etc. Okay, so that this is kind of one of the advanced methods, not the I would say the first learner methods. That is the reason I kept on asking that linear regression understanding both. It's better to understand like what's happening. Okay, so that's basically the idea of gradient descent. Now I'm open to questions. As I said, 1/2 is for the differentiation. So that's the reason for taking the 1/2 in the SSE. So that the differentiation is simple and interpretable. When I'm taking the delta of SSE by delta A and delta of SSE by delta of B. Multiple convex function में आपके multiple minima नहीं रहेंगी okay. It's usually a convex problem. No, not on LHS. Okay. New alpha beta. This is the new alpha and beta. This is the delta SSE by delta A, and your new alpha beta is this. This is your new A, which is initial A minus learning rate into delta SSE by delta A, and new beta is beta, initial beta minus learning rate into delta SSE by delta B. That's the new formulas. Okay, so this is my new A and this is my new B. Okay. What more? न्यू ग्रेडियंट यहाँ पे कैलकुलेट हो रहा है ना, डेल्टा एस सी बाई डेल्टा ए, ये हमेशा फिर से कैलकुलेट होगा, फिर आपका सी सी आया, फिर आपका ये नया डेल्टा एस सी बाई डेल्टा ए आएगा, राइट. So this is the again the new gradient. Again, this will update your alpha and beta, and that's how it will keep on updating until your sum of square is minimized. So this is how the iterations will look like. First it will 0.68, 0.55, it will go down, 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 and it may increase or remain, or the decrease may not be highly significant. So gradient is your delta SSE by delta A and delta SSE by delta B. Okay. So I hope you guys are able to get some understanding of gradients. I'm sure it's not clear at all in terms of huge explanation, because there are too many things one at a time newly, right? So understand from that perspective, right? It's 2 hour session, you cannot really grasp something which थोड़ा सा time लगता है, right? Even I started understanding फिर मेरे को समझ में आया. So what I will request is that read a bit of blogs. The Excel thing is very interesting, which I developed a kind of. Sorry. No, these are data different. That's visualization. That's a totally different thing. GD is totally different thing. Right? So, but for me, what the takeaway for you should be like, should know what is kind of gradient descent, not maybe the technicalities of it, but intuitively understand that what it does. It's basically an optimization algorithm which minimizes the cost function, updates the alpha and beta, so that your sum of square of errors and regression problem is minimized, classification, that is another cost function that is minimized. And why we are using it? Because we have to run so many models one at a time, data keeps on changing. I cannot get sit and build the models again and again, right? So GD is a very powerful technique which basically automates your regression and classification problems. And also it has been used in neural networks, classification as well as regression. So it like encompasses a lot of techniques. So that's the reason understanding it. And there are other things also like AdaGrad, Adam, Vanilla. So the variants are more. If you want to go into the detail, you can learn more about it. Right? I just talked about what is gradient, but there are its variants also. Everyone has a different kind of a minimization function, different minimization function, and that's how it works. So yeah, but I hope you were able to get a grasp of what GD is and how it works in context of. I will try to send Tani. It's kind of a property of mine, so it's being developed. So if I can, I will. Right. So let me see if I can. So offline guys, starting with you, like we're able to, again, I'm just speaking about the session, nothing into the career and stuff. One-to-one about the session, we're able to get understanding of what it is. Yes, maybe, no, maybe, or yes. Like what was your understanding percentage?
Minimize the errors.
Right.
In the basic terms, there is some, for example, in my company, there are some new creating too many errors.
Mm-hmm.
That's our managers creating some tools. But how can we catch the errors? Which skill they can create such much more errors?
Mm-hmm.
In that cases, we use this gradient.
Not necessarily, but I understand like you're speaking more from error perspective. So I'm speaking more from a regression perspective, right? So in regression, you have y and y hat. So basically minimizing the error. Okay. So but it's not about catching the errors and stuff. but it's just like you're running a problem and you're running an optimization algorithm which basically does the same thing like a regression, but in kind of a much more smoother and efficient way. That's what the GD technique is, right? So yeah, but then I appreciate that you are thinking of the cases where you can apply it. So yeah, that would be great if you can do that. Yeah. What about you, Kushbu? Are you able to go through? Understood? Yeah. And what about you? Last I hope for you it may be much more better because you when related to linear regression. हाँ टेक्निकल वाइज अगेन इन आर में मैंने कोड दिखाया नहीं है तो it's again in R there is no library of running ingredient descent just like linear regression. You have to write your own function, so that makes it code heavy. Yes, iterative function for loop for how so many models run this function. So that's how you run a gradient descent. So, but I hope you are able to understand the grasp of it. And online guys, sorry, I'm uh, kind of wrapping up more because I have to leave a bit early. But then I hope you were able to get an understanding of what gradient descent is. And if not, you can really ask me right now or any questions about this technique in particular. Which one? Which was your question? Which one? Sorry. Let me see. If you can again type in or copy paste. Okay, sir, who do not have master degree, they're actually important for this field. Okay, master degree is so masters. Okay, let's now be specific. Uh, in terms of academic qualification, something is ideal, something is okay, something is like necessary. Necessary is definitely you should be a graduate. That's very necessary. Yeah, that's I think applicable for all jobs now. Masters is preferable. Now, masters in what? Obviously, masters in let's say Hindi honor, Hindi will not do, right? No offenses to do people who have that. But masters in, let's say, if you are a computer science postgraduate, or in econometrics, or in statistics, or kind of MBA also works. So these masters really good. Otherwise, I would say suggest not to get into masters just like any random course. Yes, it just like really helps you in terms of uh, helping you to gain more attraction in terms of job calls. But I would not say it is not. It's not mandatory. It's not mandatory. Don't do it. I would say try to take certifications. Yeah, that's equally. I think that's more. Or even see of like there are courses like EC diploma, okay, in data science and data analytics. You can take up those 1 year courses, and it's not even regular. It's executive programs, so you can scout through the various courses available online, offline, and yeah, just see like whatever if you can take. If you cannot take a distance, if you cannot, distance courses simply means that you're doing it in online mode, right? So you can take it, but most of them are in online mode. If you cannot really spend entirely on study. Yeah, as I said, masters is not mandatory, but it's preferred. It's not like इसके बिना होगा नहीं, and आपको आपका रहता है तो it's like it increases the chances. That's it. Yes, why not? Why not? See, I'm saying background is not really important. It's just like understanding of this. See, it's more getting into computer science, basic mathematics. Class 12 में mathematics आना चाहिए, जैसे matrix, differentiation. These are like now the norms. And econometrics statistics थोड़ा आना चाहिए. Even if you do not have that as a background subject, you can learn it like anyways. And more is experience, more is like your on the job thinking and your ability to make sense of data. All of this will just come along. So yes, obviously it's not I am not defying the importance, but it's not like if you are a common student, it means that you will not get not get entry. That's not the case. Yes, let me see if I can. I will. Okay, and one more thing for people who are genuinely in this masterclass and if you want to attend uh, the and get a certificate, so there is a quiz, a very short quiz, right? So you can go ahead and click on this quiz, okay, and participate so that you get the certificate, right? So yeah, so just do this so that you can participate and you can have your certificates. Okay. There are a few questions of linear descent itself of what we discussed in the class. So to just be assurance of what you learned. Okay. I just pinned it in the chat box, but I cannot mail it because I do not have all the email IDs. So that's how I'm sending it. Otherwise, you can connect it with the IV. I think they have the link. Okay. Okay, perfect. So offline, guys, you wanna ask anything? You're not shocked, right? With the class?
Okay, we could do any regular classes. Only working duty for Saturday or Sunday classes.
Right. Yeah, that's the case for most of us. So that's how we have to learn. So I hope that you figured it out. Yeah. So
Each classes, the video is also provided.
yeah. All of that you can ask her because she's the most right person to talk.
So already, because we
Yeah. Please. I think they are the ones who will give you the entire. I am more in the class stuff. So all of those nitty-gritties and logistics you can just ask her like what kind of everything is there on that. But I'm just specifically asking. I hope this session was useful. It was not a waste of your time. I
all
hope
this
though.
will be taken by you.
I only take R and SAS, so I jeopardize your career in R and SAS.
In data sciences, there are some R, CS, and this one.
SQL also, visualization also. Yeah, can you ask me something? Here, here, like you asked me here, what we cover. Here we cover like the linear, the logistic, the forecasting, the clustering, the random forest, the decision trees. So these are things which we should cover. Just a learning thing. You just a learning thing. You just see it from a learning thing. It's not difficult. Yes. I come from non-programming. I already said that. I come from non-programming background, but I learned just learning. So it's not SAS is very English. You can easily pick up. R is also like once you start using it, it will be more hands-on. So that's it. That's how. Okay, so data science is an umbrella term. It's kind of superset. उसके अंदर there is ML and data analytics. So first let me tell you about data analytics. Data analytics is more about modeling, dashboarding, reporting, so on and so on. Okay. ML is a technique. So in data analytics, as I said, we usually do data analytics, courses that we cover. It's more into data analytics, and it's 80% covered into data science. So as I said, data science is super set. Okay, I will tell like what all things are in data science, which is not in data analytics, kind of. Okay, it's not a very differentiated terms. It's interchangeably used, but it's good to have it more clear knowledge, right? So data analysis is more on reporting, dashboarding, modeling, optimization, communications, so on and so forth. Techniques, where there are a lot of techniques, the ones which I said, these all come into data analytics, including tools like R, SAS, Python, SQL, Tableau, so on and so forth, right? So these are into data analytics. ML is basically just a technique, not a tool, okay? Technique of doing, of automating the problems, the techniques which I said, like regression or classification. So it's a basically a method of doing data science, a method of doing data science, simply put. ML is just a method of doing data science, machine learning. ML के अंदर बहुत कुछ आता है, supervising, supervise, unsupervised, I will not go there. Okay, it's just a method. Okay, data science, as I said, is an umbrella term. It includes a lot of things, including uh, uh, more about data also. Like if you want to deal with real-time data, if you want to deal with vision data, if you want to deal with speech data, you want to deal with sentiment data, text data, all of that, that comes into data science. There you more go into the methodological approach of building an algorithm by yourself and scaling it for production. So that is into data science. You really, in its purest form, you really build an algorithm from scratch. So imagine yourself building an algorithm for Google which predicts how many cats are here at house right now. Science. Yeah, sure. Have a nice one. Sure. Yeah, again something. So that comes in data science. I hope I was able to answer.
Which is when this data science data analytics, which would be better?
As in pre-learners, it's better before the analytics part and then you get into the data science part rather than jumping directly.
Analytics was making hard and all this.
Yes.
And data science. What is the main difference?
As I said, as I said, in analytics, I'm saying that's more into finite data. I told you about three things: speech, vision, text. When you perform analytics or science on it, and data analytics में वो नहीं आता है generally. It's more about structured data. उसमें भी आप मॉडलिंग करो, उसमें भी आप लॉजिस्टिक करो, लिनियर करो, बट आप huge real time. No, you can do that also, but that really goes into data science. Got it? So when you're talking about huge real time data, unstructured data, speech, vision, text data, neural networks, more into that scientific algorithms. Neural network is simply just a technique, okay, for predicting something uh, through a kind of a, like neurons, like brains. You think, right? You see, you feel, you see, you tell something, right? It's input and there's an output, right? So similarly, neural network, there's an input, there are a lot of hidden layers, and there's an output. So that's how in the network it's used for basically forecasting a lot of things. So like if you use your smartphone, you tell book a cab, you tell something, it interprets and it books a cab. So in between the neural network, it goes on in terms of booking a cab. So that's the example. So there's the input, there's the output, and in between there's a lot of hidden layers, which gives you the right output. Okay. So let's say if you sometimes give this image recognition, right? Image recognition, matlab, you try to log in, you enter that captcha, yeah. So you see that and you figure in that. So उसको नहीं पता है कि उसका ये आंसर है, but उसके पास बहुत सारा वैसे हैं, and whatever answer he tries to see that whether it matches, right? So for it is giving that neural network to decipher that captcha to a actual numbers what you have entered. That's the image, right? And you have entered what you have entered is text. Both the forms are different, so it runs so that both the forms are kind of equal. So that's what happens in the networks. Generally, these are examples. But in neural network, what happens is import hidden layers output. That's what the basic form of neural network is. So that more into data science. Yeah. So clear more about data science. So yeah, I mean, these are all things. Don't get confused. Take step by step, and I think as you go into the field, you become more familiar with it. So how the process. That's how the process is. And again, depends upon you that where you want to focus upon. It depends upon your career aspirations. And I cannot really comment right now, having a limited information on that. So yeah, online guys, anything you wanna ask? I will take the game and yeah, the quiz, and yeah, Shweta, I'm not sure whether you're there. I assume no. Uh, yeah. So, but one last time, Kuju, anything else you wanna ask? Otherwise, I will just officially end this session. Anything from your side? What about you? Okay, it's not there. And online guys, anything else you wanna ask? How was my birthday? Let's discuss it offline. This is good. Thank you, Abhishek, for asking. Okay, so thank you guys. Thank you all of you for attending this session, being so patient. I assume you understood some much more about the English side, and yeah, I hope you will be able to read more about it and try to apply it and get advanced understanding more in data science. All the best, and yeah, I will connect with you guys soon. Yeah. Thank you. And please take up the quiz if you want the certificates. So I have already pinned it in the chat box. You can connect to Ivy if you want to mail it to your inboxes, right? So do that. Yeah. Okay. Thank you all. Thanks. Thank you all.